Hello, people. It's time to think a little bit about physics together. I'd like to pull together some ideas from the last couple of weeks and also help you to realize that we are almost done. Oh my gosh, we have this week 5 days. The next 2 weeks are only 4 days, but you're not going to see a whole lot more content from me after next week rolls around and we get through most of it. So let's spend some time on some electrical ideas and then realize we're almost there. All right, so let's talk about some concepts. I know that you've thought about subatomic particles before. I know you've been in chemistry. I know you've seen some in earlier grades. And I know recently that you've been thinking about the word charge and the concept of charge. And I think you recognize that particular particles have this property. Charge is really a property that some particular particles have. And you know that protons have a positive charge and electrons have a negative charge. You also know that neutrons have a zero charge, and frankly, right now, we're going to kind of ignore them. Now, you also know something about the sizes of those particles. I know that you recognize protons are in the nucleus, electrons are surrounding the nucleus, but do you recognize the relative masses are really, really different? If an electron had a mass of 1, a proton would be roughly 1,860 times more massive. Now that's rough. You can go figure out exactly if you want, but that's a relative difference. In other words, protons are way more massive than electrons, which is one of the reasons that electrons are really pretty mobile. You also know about the Bohr model of the atom, and you know about the model of the nucleus and the electrons going around the outside. You probably also know that that's not entirely accurate, but it's a really good model to use, and parts of that model are very effective to illustrate some ideas. So you know that charges have a low mass. They're in the outside of the atom. And you know, periodic table-wise, that things that we call metals are located on the left-hand side of the periodic table. You know those typically are in groups 1, group 2, sometimes group 3. And on the periodic table, you also know that those things that are metals tend to have few valence electrons. So I know that you're familiar with that pretty much these atoms over here and a few in here in group 3 tend to be those that are metals. And I want to remind you that the chemistry really is important to how this works, that those atoms have electrons that are free to move in the valence shell. They're mobile, and that's exactly what causes them to be, well, metals, and also have this property of conductivity. So when atoms have few valence electrons, we give them a name, or we talk about them with a particular property, and you know that that property is that they are conductors. I guess my computer's going to take a break here. We know when electrons are small in number in the valence shell, we have conductors. We'll just assume that says few electrons over there. Just use your imagination. But when they have few electrons, we know that they are conductors. And that's useful because that allows us to think about what we can do to take advantage of those. I'm going to attempt to write the word conductors here. I'm not doing so well. We're going to abbreviate it. Conductors. There we go. So now that's kind of a basic background information that I think you've had for quite a while. And what I want you to realize now is as we begin to provide opportunity for energy to be present, you begin to notice that those charges will move. Now, I know you've had some experience with this, and I'm hopeful that one of these days the mail will show up and we'll see that you'll get a couple of light bulbs in the mail. And when you get those light bulbs in the mail, I'm going to ask you to take some wire, which you'll also get in the mail, and see what you can do to introduce a battery and make those things light. So your job is to use a light bulb and a battery to make the bulb light. Now, you can struggle a little bit with how to accomplish that. I don't think you'll have a lot of trouble. And in fact, you've probably already played with that a little bit with the PhET sim. But what I want you to recognize is that there's a word here that's really important that is a word that's probably beginning to be familiar to you, and that word is called current. And I want to help you to recognize what we mean by the word current in physics land. Current just means flow of charge. The word current means flow of charge. In other words, charge isn't a particle. Charge is a property of particles. So it's a little bit confusing to think of charge as flowing because it's really the flow of particles that happen to have charge. But the definition that works really well in our minds is flow of charge. And what that comes down to practically is that we have electrons that are moving. Now, protons can move, but they're much less likely to because of their mass. So it comes down to electrons in motion. Now, you know about how we measure current because I think you've read about it very recently, and I want to help you to think about that today. Now, we use a symbol I for current. I know that's strange. That doesn't make a lot of sense. It comes historically from the word intensity, but the concept is that current is Q over T. Now, there's another thing there that doesn't make a lot of sense. Q is the symbol that stands for charge. So when we speak of current, we're talking about charge per time. That is the flow or the motion of charge per time. In a sense, it's kind of like speed because it's a rate. But the idea is that we use the concept of charge over time. Now, you probably recognize the units. Charge is measured in a unit called coulombs, capital C for coulombs. Now, this is dangerous because a capital C looks like it could stand for current, but in fact, current is represented with an I. But charge measured in coulombs, of course, time typically measured in seconds, and current is, well, measured in coulombs per second, but as you may begin to realize, we give that unit a name, and a coulomb per second is a unit called an amp, or their full name is ampere, after a person's name, Ampere, but we tend to abbreviate that as an amp. So the point is, hey, if you have a current, and let's say it happens to be 3 amps, well, what that really tells us is that for every second you were to measure, you would see 3 coulombs worth of charge pass by a particular point per second. So current is simply a definition or a measurement of how much charge flow there is, and it's really a rate as in charge per time.